In this video, I want to go over the longest palindromic substring problem on LeetCode. Now this video is going to consist of two parts. The Blackboard section, where I go through the algorithm to solve this problem by hand, and the coding section, where we actually solve this problem with code on this website. Now before we get into any of that, I want to preface this video by clarifying exactly what this problem wants and going over some basic definitions. Now a palindrome is simply a word or a phrase that is read the same forwards as backwards. So take for example mom or dad. Mom is read forwards mom, but also the same backwards. Likewise with dad. Race car is a palindrome. Radar is a palindrome. All of those words are palindromes. Okay. Now what this problem wants us to do is, given a string s, so for this example BABAD is a string, they want us to find the longest palindrome located inside of this string. Now if we look at the answer, BAB, BAB, or ABA, all of which are of length 3, are the longest palindromic substrings inside of this string. Now we can return either one for this problem. So for example 2, CBBD is the string they give us. The longest palindromic substring is BB. And for example 3, A, the longest palindromic substring is A. Now for those of you that didn't know, letters are actually palindromes of themselves. So A is a palindrome of A and Z is a palindrome of Z. Now in the next section of this tutorial, we're going to go over the algorithm to solve this problem by hand on the blackboard. So there are a couple ways to solve this problem, but one of the most efficient ways to do it is with the expand around center algorithm. In order to understand how that algorithm works, we first need to go over some basic properties of palindromes. Now if you look over here to the word radar and CAB-BAC, you'll notice that they're both palindromes. However, radar is of length odd and CAB-BAC is of length even. Now if we were to split these two down the middle, just like so, and this one will be split here, you'll notice that odd length palindrome split down the middle will actually be right through a character. However, on the other hand, even length palindrome split down the middle will be between two different characters. So if we were to look at either side of this palindrome, we would notice that R and A are located on either side, and just on the other hand on this one, CAB is located on either side. They can all cross each other out and we will essentially be left with nothing on either side. Now given that information, we can actually find palindromes by setting a pointer, 2 pointers to the very middle position. So for odd length palindromes, 2 pointer will be at the very middle character. On the other hand, even length palindromes, 2 pointers will be on either side of the split down the middle. Now in order to find a palindrome or to check for a palindrome, all we have to do is check to see if either one of the whatever the 2 pointers are pointing to, if they equal the same letter, well then we can continuously expand on the left and right hand side, and as long as they both equal the same letter, that means we're still in a palindrome. So let's go through this real quick. We'll expand the left hand pointer by 1 position to the left to A, and the right hand pointer by 1 position to the right. Now A and A are equal, so we can do the same thing again. R and R are equal, and we would check to see if it's a palindrome in that way. Now given that information, the way our algorithm works is we loop through our string, and here's our string, BBRADARPQ, and I created 2 of them because we have to check for odd length palindromes and even length palindromes. And even though there won't be 2 separate strings, I split it up, odd and even checks, into 2 separate strings for visualization purposes. I don't want to get it all jumbled up. But we're going to loop through our string, and for every letter, we assume that it's the middle or center of a palindrome. We're then going to check each letter for odd length palindromes. So on this side, we're going to check for odd by placing 2 pointers on the very first character, because we're on the very first iteration, just like we did over here. And what we're going to do is we're going to expand outwards, just like I showed you with the word radar. And we do the same expansion method for even palindromic checks, but we place 1 pointer on the current letter. So for the very first iteration, we're going to place 1 pointer here and 1 pointer right in front of it. So we're going to place the second pointer here. The beginning and end variables shown down here keep track of not only the length of our longest palindrome, but they also hold the indices for the beginning and end of our palindromes in our string. So we're going to walk through the algorithm by hand until we find the longest palindromic substring, and that should clear things up if they haven't been already. So for our first iteration, or character B, we're going to check for palindromes of even and odd length by assuming that B is the middle of a palindrome. Now for odd length palindromes, we're going to set 2 pointers to the very middle position, and since we're assuming that B is the very middle position, we're going to have 2 pointers here. And we're going to check, does our left-hand pointer point to the same character as our right-hand pointer? Well, yes, it does. So that means that we can expand from the center by moving our left-hand pointer by 1 position to the left and our right-hand pointer by 1 position to the right. Now our left-hand pointer has left the string, so they no longer point to the same character, which means the last valid palindrome was of length 1, or B. So what we're going to do for odd is we're going to say length is equal to 1. Now on the other hand, for even length palindromes with B as our center, we're going to place our left-hand pointer to the particular character and our right-hand pointer to the one right in front of it. And we're going to check, do they point to the same letter? Well, yes, they do, so we can move our left-hand pointer by 1 position to the left and our right-hand pointer by 1 position to the right. Again, our left-hand pointer has left the string, so our last valid palindrome was of length 2. And then we need to check which is longer, the odd length palindrome centered at B or the even length palindrome centered at B? Well, the even length is 2, so that means we need to check to see if this palindrome right here that we found is longer than any other palindrome we found before. And we find this by checking to see if the current palindrome, or the current biggest palindrome, is greater than the end minus the beginning. Because remember, the end and the beginning variables store the very end and beginning indices of our longest palindrome. Okay, so since we haven't found one before, this is going to be, is 2 greater than 0? Well, yes, it is. So what we're going to do is we're going to update our end and beginning variables. Beginning is going to be set to 0 because this is the 0th indice. It starts at 0. B starts at 0. And it ends, well, with list slicing, when the very upper bounds goes up to but not including that number. So what we need to do is we need to store 1, even though this is indice 1, so this is 0, 1. What we need to do is store 1 more than this, so it's going to end at 2. Okay, so this is how this is going to work, at least for the very first iteration. So for iteration number 2, we're going to do the same thing. We're going to place 2 pointers at the second character, because that's the current letter that we're on, and we're going to check, does B equal to, or does our left hand pointer equal to our right hand pointer? And it does, so we can move our left hand pointer by 1 position to the left and our right hand pointer by 1 position to the right. They no longer equal each other, so the last valid palindrome is of length 1, which is this B, so length is equal to 1. And then we do the same thing here. Does our left hand pointer equal to our right hand pointer? It doesn't, so this length is equal to 0. And then we check which is bigger, our odd length palindrome centered at our second letter or our even length palindrome centered at our second letter. Well, our odd one is bigger, so we have to check, is it bigger than any other palindrome we have found in the past? And we find it by seeing if 1 is greater than the end, 2 minus 0 minus the beginning. So is 1 greater than 2? Because remember, our greatest palindromic substring right now is BB length 2. So is 1 greater than 2? No, it's not. So we're not going to update our beginning and end variables. We're just going to move on to the next iteration. So for iteration number 3, we're on character R, and we're going to do the same thing. We're going to check for odd length palindrome centered at R. So we're going to check, is the left hand pointer equal to the right hand pointer? It is. So we're going to move our left hand pointer by 1 position to the left and our right hand pointer by 1 position to the right. Do they equal each other? B does not equal A, so our last valid palindrome is R, length 1, so we'll say length is equal to 1. And then R and A do not equal each other, so length is equal to 0. So our longest palindrome centered at R is length 1, and we check to see if it's longer than the longest palindrome we've ever found. So 1, is it greater than end minus beginning, so 2 minus 0, 1 is not greater than 2. So we are not going to update any of our variables. What we're going to do is move on to iteration number 4. So for iteration number 4, we're on character A, and we're going to check to see for odd length palindrome centered at A. So we're going to see, does our left hand pointer equal our right hand pointer? It does. So we're going to move our left hand pointer by 1 position to the left and our right hand pointer by 1 position to the right. R does not equal D, so our last valid palindrome was A, length 1. So length is equal to 1. Likewise, for the even, it's also A does not equal D, so length is equal to 0. Which one is bigger? Our odd length palindrome centered at D is of length 1, so that's bigger than 0. So we're going to check to see if it's bigger than any palindrome we've ever found in the past by saying, is 1 greater than 2 minus 0, which is just 2? It's not, so we're going to not update our beginning and end variables, and we're going to move on to iteration number 5. So for our 5th iteration, or character D, we're going to check for odd length palindrome centered at D. So does our left hand pointer equal our right hand pointer? Well, yes, it does. So we're going to move our left hand pointer by 1 position to the left and our right hand pointer by 1 position to the right. Do they equal each other? A equals A, so we can move it again by 1 position to the left and our right hand pointer by 1 position to the right. Do they equal each other? Yes, they do. So we can do this yet again. Our left hand pointer moves 1 and our right hand pointer moves 1. Do they equal each other? B does not equal P. So our last valid palindrome was radar, length 5. So we can say this is length 5. And then we go on to our even checker centered at D, and we check, does our left hand pointer equal our right hand pointer? Well, it doesn't, so length is equal to 0. So our longest palindrome centered at D is of length 5. So what we need to do now is we need to check, is length 5 greater than any palindrome we've ever found in the past? So is 5 greater than 2 minus 0? Well, it is, because 5 is greater than 2. So what we need to do is we need to update our beginning and end variables. So I'm going to cross these out. Beginning is going to be equal to the index of the beginning of our palindrome. So 0, 1, 2. Beginning will now equal 2. End is going to be equal to the end. So this is 0, 1, 2, 3, 4, 5, 6. But plus 1, because if you remember, list slicing goes up to but not including the upper bounds that we specify. So end is going to be equal to 7. And you can check, if we do 7 minus 2, that'll be 5, which will be the length of our palindrome. But also, this is going to be the indices that we can find our palindrome in this string. Now, we can go on and continue out throughout this algorithm, but I'm sure you understand how it works. We've found the longest palindromic substring we can find in this string, because radar is the longest palindrome in this string. So at the end of this, say we continue on and we iterate throughout this entire string. At the end of it, what we can do, say this string is named S, what we can do is we can return S, beginning to end, and that'll be it. We'll return this, and this will be the same thing as returning S, 2 to 7, and what that will return is radar. So that's going to return our longest palindromic substring. And in the next section of this tutorial, we're actually going to code this out. So for the coding section of this tutorial, we're going to start out by creating 2 variables. We're going to create the beginning is equal to 0, and the next one is going to be end is equal to 0. These are the 2 variables that are going to keep track of our longest palindrome, as well as the indices of that palindrome in our string. Next, we need to create a for loop, and we're just going to iterate throughout our string. So we're just going to say for I in range of the length of our string, S. And we're just going to put a comment here. I is the center element that we expand from. Okay. So what we want to do for every iteration, just like we did on the blackboard, is we want to find the length of the odd palindrome centered at I. We want to find the length of the even palindrome centered at I, and then we want to find the longest of the 2. Okay, and the way we can do this is we're going to create a variable called length of even, or the length of odd, and we're going to set this equal to a helper function. This is the function that we're going to create in a minute, but just know for now that this function, all it does is it returns the length of the palindrome centered at I. So if we just say palindrome length, which is the name of our helper function, it's going to take in 3 input values, s, and the 2 indices that we're going to use for that particular thing. So I and I, because if you remember, for length of odd palindromes centered at I, the 2 indexes or the 2 pointers are the very same. They are pointing at I. Okay, so I, and the length of the even. So length of even is equal to palindrome length. Okay, this one's going to be a little bit different. It's still going to take in the string that we're iterating through. It's going to take in I and I plus 1. Because if you remember, for even length palindromes centered at I, the first pointer will be at I. However, the next one is going to be right in front of that. And now what we need to do is we need to find the bigger palindrome of these two odd and even palindromes. So we're just going to say longest is equal to max of the length of odd, comma length of even. So what this does is, this is a built-in function in Python, the max function. So say the length of the odd is 10 and the length of the even is 5. It would return 10 and longest would hold 10. So longest variable, all it's doing is finding the longest palindrome length from the odd and even palindromes that we have found in the past. Okay, so that's all that is doing. From here, what we need to do is we need to see if longest is greater than any palindrome we've ever found, just like we did on the blackboard. And the way we're going to do this is we're just going to say if the longest is greater than the end minus the beginning. And if this is the case, just like on the blackboard, we update these end and beginning variables with the indices of the new longest palindrome. So the way we're going to do that is we're just going to say beginning is equal to I minus the longest divided by 2 plus 1, and the end is equal to I plus the longest divided by 2 plus 1. Okay, so this is how this works. I is the very center element that we're expanding from. If we have the very center element and the length of the palindrome, because that's all this longest variable is, the length of the current longest palindrome that we have found for iteration I. But if we have the center element and the length of the current palindrome, to find the very beginning index, all we have to do is divide the length of the palindrome by 2 and subtract it from the middle index. Okay, and for the end, it's the same thing. We have the middle index, we divide the length of the palindrome by 2 and add it to the middle, and that'll give us the end index. However, if that's still unclear, we can go through an example. So the example is we're going to use the same string that we used on the blackboard before. So the palindrome is radar. I will be 4 because that is when we find the palindrome radar. That is the current iteration that we're on. And the length of radar is 5, so longest will be 5. So beginning is I, which is 4, minus the longest, which is 5 divided by 2, plus 1. Remember, beginning is just the very beginning index of our palindrome. So 5 divided by 2 is 2.5 minus 4 plus 1. So if we do 4 minus 2.5, that'll be 1.5 plus 1, which is equal to 2.5. But as you'll see in a minute, we're going to strip off all, if it is not an integer, if it is a floating point decimal number, we're going to strip off the decimal. So this is just going to be equal to 2. And if we look at the indices, this is 0, 1, 2. And beginning is in fact equal to 2 now. And likewise for the end, 4 is I plus the longest, which is 5 divided by 2 plus 1. This will be 4 plus 2.5 plus 1, which will equal 7.5. We're going to shave off that 0.5. End will equal 7, so let's check. 3, 4, 5, 6, 7. However, I know that it's on P, but in Python, when you're list slicing, it goes up to but not including the upper bounds that you specify. we're trying to specify an upper bound, which is the end of our palindrome. So what it'll actually return is R, even though it's 7. So end will be 7. And if we subtract end, which is 7, minus the beginning, which is 2, that'll in fact give us the length of our palindrome, 5. So if we count, R is 1, 2, 3, 4, 5. So that's how that works. Let's get back to coding. Okay. So we've done that. We've updated the beginning and end variables if the longest is now the new longest palindrome we have ever found. And if that's basically it for this function, we're just going to return, because after we've iterated throughout every single character in our string, we are done. We found the longest palindrome, so we're just going to return. What we're going to return is S, and we're going to return beginning, end, just like we did on the blackboard. I don't know what that is, so beginning and end. However, remember, there can be decimal points, so we're just going to convert these into integers, and that'll shave off any decimal point that we may encounter. So we're just going to say int there. The last thing we need to do is to create our helper function. This is the function that I was talking about up here, the palindrome length function right here. So the way we're going to do this is we're just going to say define palindrome length, so palindrome length. This is going to take in the input values that we have specified up here. However, we're going to call them a little bit different. S is going to remain the same, and this is just going to be left IDX and right IDX. So right IDX. So the first thing we want to do is we want to make sure our pointers stay in our string. If you remember back to the blackboard, when we were iterating throughout our string, our left-hand pointer actually left the string, and we don't want that to happen. So we're just going to create a while loop, and we're just going to say while our left IDX is greater than or equal to 0, because if it's less than 0, that means that the index is less than 0, and 0 is the start of our string, so it can't be less than 0. And right IDX is less than the length of the string, less than the length of our string S. Okay. While that is true, so while our pointers, our left and right pointers are in our string, we need to check to see if our left and right hand pointers are equal to each other. And we can do this with a simple if statement. So we're just going to say if S of our left index, so left IDX, does not equal the right S of the right IDX. So if they are not equal, what we're going to do is we're going to break out of this while loop. Okay, so this will continuously run until either the left hand pointer or the right hand pointer leave our string, or the left pointer is not pointing to the same letter that the right pointer is. So what we're going to do while all that is the case, while all it is true, is we're going to decrement the left index by 1 and increment the right index by 1. So we're just going to say left IDX minus equal 1, and right IDX plus equals 1. Okay, so we are basically done with this function. So if any of these things happen, the left index goes too far left, the right index goes too far right, the left pointer is not pointing to the same letter that the right pointer is, we're going to return the length of the palindrome we have just found, and we can do this by saying return right IDX minus left IDX minus 1. And if you don't understand how that works, let me show you right here. I wrote this out as well. Okay, so let's take, for example, radar. Say we found this is the longest palindrome that we have just found, R and R. If we go back to the code, as you can see, R and R are equal to so it's going to add 1 to our right and left to our right index. So it says while, or if the left pointer is not pointing to the right pointer, it's going to break. But for R and R, they are equal. So it's going to decrement our left pointer by 1 and increment our right pointer by 1. So when it goes back up here, they won't be equal and it'll break. So what that means is our left index will be 1 too far left and our right index will be 1 too far right. So let's go back to this. So even though radar is our palindrome, what it's going to return is this and this. So from this string from B to P. So this is the indices 0, 1, 2, 3, 4, 5, 6, 7, 8. So what this is going to return, our right index will be P, so 7, minus our left index, which will be 1, minus 1. So what this is equal to is 5. If you look, this is actually true because this function's only purpose is to return the length of the palindrome. If we count the length of the palindrome, our radar palindrome, so this is 1, 2, 3, 4, 5, that works. So let's go back to this and let's go back to this problem and let's test it. So this is it, this should be it, and it should work. So let's run the code and see what it does down here. Oh yeah, okay, so in LeetCode, for some odd reason, we can't use a helper function inside of a class, I guess because you need this self parameter. So this will work anywhere else but self, and then we need to do self dot palindrome length for each one of these. So self dot palindrome length for each one of our functions. Now if we run this code, it should work. Number 8. Oh, minus, so that should be equal to just being equals. So let's test it again. Let's see if this works, hopefully. What is going on? Palindrome spelled wrong, so palindrome. Okay, run code. Accepted, let's submit it, see how it works. Okay, it was a success. So that is the longest palindromic substring problem in Python. I hope that you learned something, and if you did, I would appreciate it if you liked, commented, and subscribed, and I will see you guys in future videos.